Hey, good afternoon, everyone. Welcome to our Tuesday 2 o'clock webinar. My name is Chad, and I will be your host as we discuss formulas in Envisioneer today. So before we get started, just wanted to go over the ground rules and how the webinars work here. So what I'm going to do here shortly is give my formal presentation about formulas, and then after the presentation, I will open up the question panel, and you can type in any questions that you might have, whether it's during the webinar or at the end of the webinar, into the questions section on the GoToWebinar panel, and I will do my best to answer those questions live online. The other thing is, after the webinar, I will also be sending out an email, and included in that email will be a booklet, a PDF file that you can take and look at on your own time and do some of the exercises that we go over in the class here as well. So let's go ahead and get started. So just like every Tuesday morning, I've been working really hard, and I was able to come up with a model here. So what I've got is 4 walls, a roof, a set of stairs, and a fence that I've inserted into this model. And what we're going to do is look at the formulas and how we create the formulas to calculate the parts that make up the fence, the stairs, the roof, and the walls. First item we're going to look at is the fence. So I'm just going to come and simply select on that fence by left-clicking. A right-click will bring up my options for that selected element, and in this case I want to look at the properties of the fence. So click on Properties. We can see we've got 3 tabs here that make up the fence. The Basic, where we've got all of our different settings. The Appearance tab, where we've got our materials and our patterns and our different components and layers that we can set. But most importantly for today's webinar, we want to look at the Quantity tab. So we can see here for this 4-foot standard wood fence that's been inserted, what we've done is draw this fence in. We can see it's got a specific length. I don't remember exactly what that length was, but we've drawn it in, just clicking 2 points to create a length of fence. So then what we want to do is to be able to not just report the length of the fence in our quantity takeoff. We want to be able to tell how many posts there are, how many boards, how many fence boards there are, how many rails there are, if there is lattice, if we want to calculate screws or brackets, all that kind of stuff. What we need to do is attach those as assemblies onto the fence so that those separate materials can get calculated as well. So we can see here what we do have attached for assemblies on this fence. We've got a 1x6 fence, one side with no spacing assembly. So what we're calculating here is the 2x4 rails at 8 foot long, as well as the 1x6 fence boards. The next assembly we've got attached is the fence length, so just a general report on the length of the actual fence. And lastly, we've got the 8-foot 4x4 posts, so 8 foot on center with 8-foot posts. That's what we're calculating with the last assembly that's attached. So we can see each assembly is made up of a product, the formula, and the unit of measure on the product. So when it comes to calculating the fence length, all we're doing for the formula is looking at the length of the fence. So it's going to look at how long this fence actually is and simply report that length for us. The unit of measure is related back to the actual product itself. So since we're calculating fence length, the unit of measure on the fence length part that we've created is lineal feet. So that's simply why we've got the formula calling out length. We just need a lineal foot calculation for the length of the fence. When it comes to the 4x4 8-foot pressure-treated post, we can see we've got the formula here that's a little bit deeper than just simply the length of the fence. We're taking the length of the fence, dividing by 8 and adding 1, and we'll go over how to create that formula and what that formula means in a second. But also with that, each unit of measure, again referring back to this product, we want to find out how many 8-foot posts. Not the overall length of all of the posts, but we want to break it down into individual 8-foot posts. So those are the keys when we're looking at creating assemblies and creating formulas, is the parts that we're calculating, what unit of measure are they using, or what unit of measure are we looking to calculate, and to calculate those, we input an actual formula to create those. So before we go too much further into the actual editing of a formula, I just want to let everyone know that with Building Essentials and Construction Suite, the top 2-tier products that we offer, you will be able to edit these formulas. If you are a Pro Architect user, the only thing you'll be able to do is actually view these formulas. They are actually attached as generic formulas for most of the elements in your catalog, but with Pro Architect you are not able to actually edit any of the formulas. So what you see is kind of what you get with the Pro Architect. But when it comes to Building Essentials or Construction Suite, anything we do here with the formulas and the customization, you will be able to do with those two products. So with that out of the way, let's go in and look at how we edit and create formulas. So I'm going to start off with the fence post option, the 4x4 8. To go in and edit this assembly, I'm just simply going to click on it, whether it's the header or an element within the assembly itself, and I'm simply going to come up and edit that assembly. So when I click on Edit, that brings up our assembly dialog box. We can see all of the different assemblies that we've got set up for fences. So under the fences section, we've got stucco components, rough stone fence components, ranch fence, alternator fence, picket fences. So lots of different fence options, each with its own distinct formulas that make up those fences for calculating the specific products in each of those fences. When it comes to the post folder, we can see that we've got 8-foot spacing. We've got 8-foot posts or 10-foot posts or 12-foot posts. So depending on the height of your fence, you may want to apply different post height assemblies to calculate the proper length of post that you're going to need. And then just simply the measurements folder, which we have that one single fence length assembly in there that will just give us a generic length of the fence as a unit in our quantity report as well. So back looking at the posts, we can see here we've got our 8-foot on center with our 8-foot post. This is the one that is attached to this fence that we're doing here. We can see all of the elements within this assembly. So if we look, when we select on here, we've got the 4x4 8 treated posts. That is the only elements in this assembly. So if we've got more assemblies that have more items in them, all of those items will be listed here in the contained list. So going into customize this quote or look at how we create the quantities here, I'm going to right-click on the assembly that we've got here. We've got a couple of different options. We can add new assemblies if we want. So if there's an assembly in here that we don't have, we can add anything new. We've also got the option to edit the assembly. So I'm just going to simply click on Edit, and that's going to allow me to come in and edit the 8-foot post assembly. So we can see the Edit Assembly dialog is made up of a little chart here. We've got the actual element itself, so our 4x4 8 treated post. And if there was more than one element in this assembly, they would all be listed here. Then we've got a calculated quantity. So for each element that we would have listed here, each of them would have a calculated quantity or where we insert the formula. We'd see the units of measure, and we've also got the option to apply custom usages and phases in each assembly as well. So to look at the formula itself, we've got the proper product here. We want to go in and deal with the formula. When I click on the cell, we get the ellipse button that comes up here, the button that's got the 3 dots. And when we click on that, that allows us to come in and edit or define the formula itself. So we can see here up in the top of the dialog box, we've got the actual formula. So these formulas will follow Excel syntax. They also follow order of operations. So you'll see lots of brackets being used in these formulas so that we're doing specific operations before other operations within the formula so that we can get our formulas calculating the correct quantities. So a formula is made up of different variables. So variables are what the program is going to be figuring out for us. So we can see here the length variable is being used in this formula. The program knows the length of the fence because we've drawn it in. The program has a scale set to it. It can report to us the length of the fence. So we're going to use that variable to calculate how many posts we're going to need. You can see all of the different variables that are available. We've got the area of the fence that can be used. Count is just going to count the number of fences that actually get inserted. So if you have 3 different fences inserted into your drawing, you're going to get a count of 3 when it comes to using the count variable. I've also got the fence height, the length of the fence, and then different variables as well that can be used here. We can see price, quantity, volume, different variables that can be used. Some of them not necessarily going to calculate a number. So some of the times you're going to want to just limit these to the variables that will calculate numbers for you. So in the fence, we don't have too many variables that we can use, but when we look at the roof later, we'll be able to see all of the different variables that might be available in a different element like that roof. So when it comes to creating the formula, basically what we've got here is the length divided by 8 is the first operation we're going to do. We can see that it's in brackets. We're going to do that operation first. So if I take and just draw a picture off to the side here, we've got the length of the fence, and we're going to have our posts that we want to calculate at 8-foot centers. So we can see all the posts that we've got there. In order to get the number of posts that we need, we're going to take the length and divide it by 8. That's going to give us the number of posts, and then we're adding on 1 so that we add on that beginning post, because as we start to divide our length, the first 8 feet is going to calculate that first post at 8 foot, but it's not going to calculate that very first post in the line. So that's why we're adding on 1 at the end, and that's essentially what we're doing with this formula. Taking the entire length of the fence, dividing by 8, adding on 1 for the start or the end post, and that's going to give us the number of posts that we need for this fence. We've also got the ability, we've got a test option here, that if you go in and test this formula to make sure that it's correct, because we want to be careful with brackets. When we open brackets, we want to make sure we close a bracket. We don't want more opening brackets than we have closing brackets, and vice versa. We don't want more closing brackets than we have opening brackets, or our formula is not going to work. So we do have the test option here, and just to show you how the test works, if I come in here, we've got the formula here that we want to calculate, and here's all the different variables, and all we're going to do is put in a value for the variable. So when it comes to the length, we want to take and assume we're going to have a 32-foot long fence. So I'm going to type in 32. It's going to represent 32 feet, and we should get a calculation that gives us 5 posts. We're going to have 4 sections at 8 feet, so it's going to be 4 posts, and then our starting post will give us a 5th post. So when I press enter here, if this formula is inputted correctly, we should get a value that equals 5. There we go, length 32 gives us 5 posts. So that's how we can take and test and make sure that our formula is working correctly as well. So if we had multiple variables in here, maybe we've got length and fence height all in the same formula. When we're in the test section here, we're going to want to make sure we have a value for a length and a value for our fence height so that it can include both those variables to accommodate our test and make sure that the test is correct. So that's how we can create a formula. If we just close out of here, actually, sorry, just to explain the formula box a little bit further, we've also got, we can type in everything here. So we can type in length, the slash for divided by, the number 8. We've also got the keypad over here where we can actually click and input the numbers as well. So we can see if I'm inside the box here and I'm just clicking on all of these operators, I can create my formula by clicking on them. I can also create it by just simply typing on my keyboard. So the star or the asterisk is the multiply by function. The slash or the, I guess the slash is the divided by function. So when you're using your keyboard, those apply as well. We've also got different functions down here that we can use, min, max, average, trunk, square root, different functions that we can use as part of our formulas to calculate different items as well. When it comes to variables, we want to make sure our formula matches these variables. Usually what we recommend is actually clicking on the variable. So if we want to create length, rather than typing it out, we would actually just simply click it, and it will automatically put it into the formula. So you can come in, spaces do not matter, so I can put a space in and then divided by, just to space this out a little bit, another space. Again, I can type my 8, or I can just simply click the 8 on the keypad here. I want to make sure I include my brackets. I want to do this operation first. So back to the start, I'm going to do an opening bracket. Got my length divided by 8, and I just simply want to add or plus 1, and there, that's how we can write out a formula. So we've got our variables, we've got our keypads and our functions that we can use and click and type in our formula. The other option we've got down here is the input. So when we're dealing with the divided by 8, we're dealing with the length of the fence in feet. Every 8 feet we want to post. So we want to make sure down here in our input area that we are using the foot or feet variable for our length. If we had any objects in here that dealt with area, you can see here this units is set to square feet. If we were dealing with metric or square yards, for example, you're going to want to make sure that your formula is going to be calculating based on those proper variables. So if in fact the area you're looking for is calculating in square feet, you can just leave your area here. But you can see also in the length we've got millimeters, centimeters, and meters if you're in metric, or you can do inches and feet. If I had this set to inches, my input length to inches, every 8 inches, so our length in inches divided by 8 plus 1 is going to give us a post every 8 inches. So if you ever find that you're getting 12 times the quantity that you're looking for, that's the first place to come back and check and make sure your input length is dealing with the same unit that your formula is dealing with. So that's our post formula and how we're calculating the number of posts. When we've got that all saved and done correctly, we can click OK, and click OK to apply that assembly to our 4-foot standard fence. Next, I'm going to look at the fence boards and the rails. I'm going to come back in and select that assembly, click on Edit, and come in and edit this type of fence. Again, I'm going to right-click. I can add a new one, or in this case, we're going to edit. And we can see that we've got 2 products here now, our 2x4 8 treated and our 1x6 treated fence board. If we notice our 2x4 8 is set to units of each, we want to calculate the number of 8-foot boards. With the fence board, our unit is set to lineal foot. So what we're calculating is the overall lineal footage of our fence boards, not specifically 5 foot, 6 foot, or whatever length, but an overall lineal footage. So when we're defining our formulas are going to be defined accordingly depending on what we're looking to calculate. So if we start off looking at the 2x4 8 treated boards, and these are going to be the rails that our fence boards are going to attach to. Very similar to our post formula, we're taking the length and dividing by 8. We want to take our fence and divide it into 8-foot sections. If you're doing 6-foot or 10-foot sections, whatever your case may be for your fence, you would set these formulas accordingly. So our length divided by 8 is going to give us the number of rails we need per section. And multiplying by 3, or sorry, the length divided by 8 is going to give us the number of 8-foot sections. And then multiplying by 3, in this case we're assuming 3 rails per section, is going to give us the total number of rails, or the total number of 2x4 8s. So if we look at that in an elevation view, and we take and we've got a post, and a post, and a post, what we're looking at is probably a rail at the top, a rail at the bottom, and a rail in the center to support our fence boards. So length divided by 8 is going to give us the number of sections that we need, and each section has 3 rails. That's why we're multiplying by 3, and that's where we get the formula. Our input length we've got set to feet because we're dealing with 8 feet when we're talking about our length of sections. So that's why we've got our input length set properly. So that's looking at the rails. Next, if we take and look at the fence boards themselves, how we're calculating the fence boards, click on that formula, click the ellipse button, brings me into my define formula dialog. We can see a lot longer formula here now. A couple more brackets, so we've got each section set into its own set of brackets. First operation here, we can see length multiplied by 12. So what that's doing is taking and we've got our length, our input length set to feet. The length multiplied by 12 is setting that length to inches. So we're getting the number of inches, the length of the fence in inches. And the reason we're doing that is because we're dividing by 5.5. 5.5 being the number of inches wide that our 1x6 board is. So the 1x6 is 5.5 inches wide. Our length multiplied by 12 gets us to the inch unit. Dividing by 5.5 is going to give us the total number of boards that we require. So once we get the total number of boards based on the overall length, we can then multiply by the height of the fence, and that's going to give us the overall lineal footage for our fence boards. We can see here, if we move this out of the way, we are looking for the lineal footage of our 1x6 treated fence board. We're not breaking it down into specific lengths, but looking for the overall lineal footage. If we were breaking this down into lengths, we might take our formula, and we could probably just break it down into be length multiplied by 12 and divided by 5.5, and that would give us the number of boards that we require, and the item itself would have the specific length that we'd be looking for. So if that's the case, your formula can be simplified. It can actually even be simplified further if you just went length divided by 5.5, and we set our input units to inches, and that formula would also give us the number of boards that we require along the length of the fence. So the assumption here is that these boards have no spacing, they're just butting up against each other. So depending on the different types of fences, your formula might change as well, depending on how the boards, whether they're staggered on each side or whether there's a gap in between them. So each formula can be a little bit different, but you've got the ability to customize the formulas however you need to. Just going to cancel out of that formula so it goes back to the original, and take and cancel that and cancel out of here. So that is our fence and the different assemblies that are attached to our fence and how the formulas are working for those fences. So the next item I want to look at is the roof. If I take and select the roof here, we can see that we get each individual edge of the roof has our arrows. We've set and defined our roof. What we want to do again to look at our formulas, with that roof selected, we're going to right-click and go into our properties. In the properties dialog, we want to go to our quantity tab. This is where all of our different assemblies are housed, and we can see the multiple assemblies that we've got attached here. So we've got the shingled roof finish assembly, which is going to calculate the actual shingles, the hip and ridge cap, the starter shingle, and the nails to hold down the shingles. We've got the sheeting, so the sheeting and the sheeting nails for the sheeting that are calculated. Another assembly again, the components that go underneath the shingles are underlay, drip edge, any valley flashing, ice and water shield, ridge vent. Those are all being calculated. Just like our fence, we've got the element, we've got the calculated quantity, and we've got a unit of measure that we're calculating for each item. Subfascia is being calculated, our soffit and fascia, so our aluminum soffit, soffit screws, 10-foot fascia, and 12-foot soffit channel. also being calculated here based on the roof properties. We can see roof framing nails. So for every 1,500 square feet of roof area, calculate a box of nails. So we can get down right to as little calculations as possible if we just wanted a square foot roof calculation, or we can get right down into many parts and pieces. As long as we can use one of the variables that the program is going to figure out for us and create a formula, we're able to calculate all of these different items. So if we take and look at our shingled roof finish formula or assembly, I'm going to take and select it and click on Edit. Again, we can see that we've got the different types of assemblies. We've got different finishes, different components, different fasteners, all different groups that have their own set of assemblies. You can see here in the finishes, we've got shingles, we've got wood shakes, we've got clay tiles, and we've got metal roof. We can see in each one of them what each assembly contains. And if we right-click, we've got the option to add or edit new assemblies. In the shingled roof finish, we can see all of the different components listed here. We got the shingles themselves, hip and ridge cap, starter shingle, and coil nails. So when it comes to the shingles themselves, we can see that we're taking the area, dividing by 25, and multiplying by 1.05. So if we look at that a little bit deeper, this is a little bit different formula here. So we're taking the area. We can see all of the different variables that are available in a roof. You can see we've got area, which is going to be the sloping area, not the flat area of the roof, but the sloping area based on the pitch of the roof. A count, again, the number of different roofs that would be inserted into a drawing. Fascia length, gable soffit area, hip length, length, opening perimeter. We got ridge length here as well. If we keep going down, we can see all of the different variables. Roof opening area, roof soffit area, valley length. So any of those different variables that the program is going to figure out based on the roof that we've drawn, we can use those variables to calculate our materials. So when it comes to the shingles, we've got area divided by 25. So this is assuming 4 bundles per square, so 25 square feet in a bundle. If we wanted to do this as a 3 bundle to the square, we could take and do our area divided by 33, would give us the number of bundles in that situation. And then what we've got is we put that first operation in brackets, and we're multiplying by 1.05. And what that's doing is calculating a waste factor for us. So 1.05 is basically 105% of what we get for our area divided by 33 calculation. So basically 5% extra than what we would need. So that's how we would normally handle a waste percentage in our formulas. So when we're calculating area divided by 33, that's going to get us to a very precise decimal number, and then round up to the nearest bundle. If we want to add on our 5% or 10%, whatever waste factor we want, it's just a matter of multiplying that by a percentage factor. So it's going to calculate the area or the number of bundles of shingles for us. We can see our input length here is set to inches, but we don't have anything dealing with the length in this formula. All we're dealing with is area, and we've got the area set to square feet because our 33 is the number of square feet in a bundle of shingles. So when we change that up, we can click OK. We've changed that formula now to be area divided by 33 rather than 25, and this assembly will calculate 3 bundles of shingles per square. Hip and ridge cap, again, if we go in and look at the formula, we can see that we're taking the ridge length, adding on the hip length, and that's going to give us the total lineal footage that we need for hip and ridge. Then we're dividing by 30. In this case, our hip and ridge shingles cover a length of 30 feet, so that's going to give us the number of bundles. So depending on whether it's an actual hip and ridge cap itself or whether it's a 3-tab shingle that you're creating and using for your hip and ridge, you can take and change this number here depending on how many lineal feet each bundle covers. So whether it's 33, 30, 25, whatever that length is that your hip and ridge covers, it's just a matter of adjusting your formula accordingly. Starter shingle, same idea. We can see here if we go into the formula, fascia length divided by 120. So we're assuming here fascia length being basically the eave length, or any length of fascia that is perpendicular, is parallel to the ground. So any sloping fascia is considered gable. Anything that is flat and parallel to the ground is considered fascia length or eave length. And we can take and use that. Our starter shingle in this case, we're just using on that fascia length, and we aren't running any starter up our gables. So the variable we're using is simply just the fascia length. In this case, we've got an actual bundle of starter shingle that covers 120 lineal feet. So since we're dealing with feet, 120 is lineal feet. We're making sure our input length is feet. If we, again, we're using the 3-in-1 bundle, or maybe it only covers 70 or 80 lineal feet, just be a matter of changing this number here in our formula to represent the coverage of the bundles that we're actually using. And roof coil nails, we've just got simply an area divided by 2250 or 2,250. So for every 2,250 square feet, I'm going to need a box of roof coil nails. So that's looking at the shingle finish. Just going to cancel out of that, clear my drawings here. The next one I'll look at is the shingle roofing components. Take and edit that. And if we go into exterior components, shingle roofing components, we can see all of the different components that we've got here. Our 15-pound felt paper, just simply taking the area, dividing by 400. The unit for our felt paper is roll. So our rolls are 400 square feet. We're just simply taking the area divided by 400 to cover the entire roof with our felt paper. Drip edge, if we take and come in and look at our formula there, we're just simply adding fascia length plus gable length. So any length of fascia, whether it's gable or whether it's the fascia, we're going to add in this drip edge. The drip edge is 10 feet long, so we're just dividing the entire total by 10 feet. Again, if we wanted to put waste on here, we do want to make sure that we put our entire formula in brackets. So I'm going to include an ending bracket. I'm going to put in a second starting bracket, and I'm just going to multiply this by 1.1 is going to give me 10% waste on this. So it's as easy as that to add in for a waste factor. Take and click OK, and now that new formula has been saved. Valley flashing, we're taking that valley length variable, dividing by 50, because we have 50-foot rolls. If it was 10-foot sheets, obviously your valley length divided by 10 would give you the number of sheets that you require. Ice and water shield. In this case, we're doing ice and water one row along our fascia length, or anything parallel to the ground, as well as adding in our ice and water for the valleys. So that's why we're adding those both together. If you didn't do your valleys, put ice and water in your valleys and just did your fascia length, your formula would just simply be fascia length divided by 65, or whatever the length of the roll of ice and water that you're using would be. So again, totally customizable how we can create these formulas for each different material, each different element that we've got. And then lastly, we've got our ridge vent. They're 4 feet long, so we're just simply taking our ridge length and dividing by 4. Every 4 feet of ridge, give me a separate ridge vent, and that's going to give us the number that we need. So that is the roofs and all of the different variables that we can see that are being used there for the roofs, all the different lengths of the roof for all the different products. Again, as long as we can find a variable that can be used, we're going to be able to calculate whatever types of products we want. So that's the roof. Next, I just quickly want to look at walls. So if I take and select this back wall here, and right-click with it selected, go into the properties. Again, we want to look at the quantity tab here. So we've got our walls. We've got 4 walls here, and we've got our assemblies that are attached to this wall. If I just quickly draw what this wall looks like. So we've got our vinyl siding, and we've got our sheathing, and we've got our stud portion of the wall. It's got a plate on the bottom, and then what we've got here would be the floor system. So we're assuming this would be on a first floor that's got a frame floor system. So what we've got is the exterior side is a little bit lower than what the interior side would be. So interior side is going to go to the top of the floor system. The exterior side is going to go to the bottom of that floor system. We can see here our variables deal with exterior wall area and interior wall area. So depending on what you need to calculate, you can use the appropriate variable. The other thing is when it comes to exterior versus interior, when we've got an enclosed perimeter of a building like we do here with our square house, once the perimeter gets enclosed, the program is intelligent enough to know that the outside is the exterior and anything on the inside is the interior. So on an exterior wall, when we're using interior wall area for the drywall, the program is intelligent enough to know that just the inside portion or just one side of that wall is going to calculate for interior wall area. Also for the exterior, if it's an exterior wall, it's going to know that the exterior side, just one side of that wall only, and it's going to know if it's got that drop face bottom on it to calculate that extra depth for the floor system as well. So we can take and use those variables to our advantage where the different heights come into play there. So looking at our OSB sheeting with Housewrap, if I take and edit that and double-click, double-click will also come in to edit an item rather than right-clicking and edit. You can simply double-click on an assembly and that will come in and edit as well. We can see our Housewrap, 9 by 100 square foot roll, so 900 square feet in a roll. If we take and look at our formula, we can see we've got exterior wall area plus opening area, and we're dividing that all by 900. So by default, if we were to put a window into this wall, the area of that window would automatically get subtracted from this exterior wall area. So a product like Housewrap that you're probably just going to take and roll right over top of a window, you're going to want to make sure that you add that area back in there so that you're going to get enough product to cover those windows. So in this case, that's why we're taking the exterior wall area, adding back in the opening area, and then dividing by our 900. Same idea with the sheathing tape. If we take and look at that, essentially we're saying for every 1,000 square feet, it's going to be a roll of tape that's required. And again, we're adding in that opening area so that it gets calculated in our calculation as well. The OSB sheathing is going to be the same idea, opening area, adding back in the, exterior wall area, adding back in the opening area, dividing by 32, 32 being the size of a 4x8 sheet of OSB sheeting. If that was a 4x9 sheet, obviously your division would be by 36. If it was a 4x10 sheet, your division would be divided by 40. So again, depending on what you're calculating, your formula can change and the numbers may change based on the sizes of the different elements. So that's exterior options. Again, that's going to calculate to the bottom of your floor system and only on the outside of an exterior wall. If we take and look at the drywall and take and edit our 1/2-inch drywall, double click on it to go and look at the formulas here, we can see in the case of the drywall we've got 4x12 sheets that are being calculated. So we're taking our interior wall area. On the exterior wall, it knows that that is just one side. If we've got an interior wall, so we've got an interior wall that's attached here, if it's inside the perimeter of the building, the program is smart enough to know that this wall is going to have two sides that are interior. We don't need to take our formula and multiply it all by 2 to get to two sides. It knows that this interior wall has two sides of interior wall area, and this exterior wall only has one side of interior wall area. So we just need to use that interior wall area variable and not worry about the number of sides of the wall itself. So interior wall area plus the opening area, and dividing that by 48, 48 being for the 4x12 sheet. Drywall, maybe you want to calculate that a little bit tighter and not worry about going over top of your openings, and just simply removing those openings from your calculation. Just be a matter of taking and deleting that out. So interior wall area divided by 48. Now the interior wall area there is inside brackets. That does not matter. There's no operation that's actually going on there, but the brackets are equal. There's one opening bracket, one closing bracket. If we had two closing brackets here, though, this formula actually would not work. We've got more closing brackets than we do opening brackets, so this formula is incorrect and will not actually give us a value. So we want to be careful when we're defining these formulas. Rather than typing the variables, we'll click on a variable to actually insert it into the formula and make sure that we're typing them correctly and using the proper number of brackets. Looking at the joint tape, you can see we've got a really long formula here. So 3 opening brackets, we want to make sure we got 3 closing brackets, which we do. We're taking the interior wall area, adding in the opening area, so we're assuming we're drywalling over the opening here. Dividing by 32, so it's going to give us the number of 4x8 sheets that might be required. Then we're multiplying by 12. 12 feet, I believe, is coming from 2 edges of that sheet, one 4-foot edge, one 8-foot edge. So it's going to give us the length to tape half a sheet. And then we're taking that entire value for the overall length of tape that we need, dividing by 500, 500 being the total lineal feet in a roll, and that's going to give us the number of rolls of tape that we need. In this case, our numbers are all dealing with areas, so interior wall area plus the opening area. We've got that set to square feet. Our input length, even though we've got 500 feet here, any of the calculations that we're doing are just square foot calculations with the variables, so we don't need to worry and put this to length. If by habit you want to actually make and change that to feet all the time, it does default to inches when you're creating formulas. You can take and just set that for peace of mind. So that is the wall formulas and variables that we've got available. Sorry if I just go back in there and look at the different variables we've got for our wall. You can see we've got area, we've got count, we've got exterior length, which will be the outside length, interior length. Again, if it's an exterior wall, we'll only calculate length of one side of the wall. If it's a wall on the inside, the interior length will calculate the length of both sides of that wall. Interior wall area, same thing. Length, just the standard length is going to go from the center line of the wall. Opening area, obviously that's the area of any of your openings, and we need to remember that opening area does come out of our interior areas or our exterior areas if they apply. I've also got exterior sides, interior sides, volume of the door, width of a wall, volume of a wall. All of these different units can be used. And again, when it comes to volume, we've got an input length here that if it's cubic meters, cubic feet, or cubic yards, you're going to want to make sure that you've got your input length set properly. So that's the walls there. The last thing I want to do is come in and look at these stairs. Right-click, come into the properties of the stair here. And we want to go to the quantity tab. We can see that we don't have any assemblies attached to this stair. So what we're going to do is go through the exercise and create a couple of items that we want to calculate for the stairs. First thing I want to do is add a new assembly. We can see that we don't have any assemblies here. So click to edit stairs and ramps. I'm going to take and edit that assembly. First thing I can do is give it a name. So I'm just going to simply call it Stair Parts. You can give any of these assemblies any names that you want simply by typing it in. We can see we don't have any products here. So what we want to do here is add in a product. So first off, if we want to do some treads, we want to calculate the number of treads in a stair. I'm going to come into my lumber and maybe I want to use 2x10/16 for treads. Take and select the part that I want, my 2x10/16, and click OK. And I've added that in to my assembly. Now the calculated quantity, I want to create the formula to calculate how many 2x10/16s I need for each stair. So I can take here, and here's my defined formula box. I don't have a formula created. So the first thing I'm going to do is figure out the number of treads in the stair. So if we come down here, we can see we've got a variable here, total risers floor to floor. So I can take that and use that as a variable, total risers floor to floor. Now that's going to calculate the risers. Usually the number of treads is one less than the number of risers. So if that's the case, I'm going to take total risers floor to floor and subtract 1. I'm going to make sure I put that in brackets to do that operation first. And the next thing I need to do is I'm calculating the number of 16-foot boards. So this is going to give me the number, or the total number of risers, but I need to get this into the number of 16-foot boards I need. So unfortunately, we don't have a tread width or a stair width variable here. So you got to assume your different widths. So if you standardly normally use 3-foot width stairs or 4-foot width stairs, your formula here is going to apply to that. So let's assume that we're going to have 4-foot wide stair. Our total risers floor to floor minus 1. And since our stairs are 4 feet wide, we should be able to get 4 pieces of 16-foot material for each tread. I'm just going to simply take the total number of treads and divide it by 4. Again, since we're not using any input length here, we're not dealing with feet when it comes to the total risers floor to floor or an area. We don't have to worry about our input. We can take and OK this, and we should get the number of 16-foot boards we need for this stair. Next, if I want to add a new item, come in here, and maybe I want to do my risers here. So I don't have any 1x8 material. I'll just use the 2x8 material here for a riser. Take and click OK. And same idea, I'm going to come in my calculated formula and insert my formula. Well, since we're dealing with risers, we can probably take our total risers floor to floor. We don't need to subtract 1 because this is the actual risers we're trying to calculate here. And I can just take that, and just like I did with the treads, we're going to assume my stairs are 4 feet here, and take and divide this by 4. It's going to give me the number of 16-foot boards I need for this stair. Again, input length doesn't matter here. I'm dealing with total risers, not an actual length. I can carry on, click OK. Just because we're dealing with specific measurements here, I'm actually going to change my name and make it Stair Parts for 4-foot width. So maybe you might have a different calculation if you've got a 3-foot width stair or a 5-foot width stair. You can have separate assemblies for each of those where your formula might be a little bit different. And then lastly, what I want to do here is calculate the risers, the stringers. I'm going to take and add a brand new item here, my 2x12/16. I'm going to use for my stringers. Take and add that in. And in my calculated quantity, I'm going to come in and create the formula for my stringers. Now we don't have an overall length of stringer or anything like that. So what we're going to do is get creative with our formula and summon our inner Pythagorean theorem. So what we've got, if we look at the Pythagorean theorem, is the right angle triangle. So we've got here a couple of variables that we can use, the length and the overall height. So we've got length here, we've got overall height here, and to get the actual stringer length is going to be our hypotenuse, or x, and our formula is going to be length squared plus the height squared, overall height in this case, and that's going to equal our hypotenuse squared. So we can express that in our formula here. So to do that, what we're going to do is take our length and we're going to square it. So we've got our little hat here is the exponent. So we want to go length to the exponent of 2, and we want to make sure that we've got that in brackets to do that operation first. Then we want to take length squared plus, so we'll take and add that. I'm going to start an opening bracket, and we want our overall height squared, so our overall height value variable to the power of 2, and put that in brackets. So it gets this part of it, and that equals x squared. So what we can do is take the square root of this section, and that will give us our x value. So what I'm going to do is take and go to the start here. We've got the square root option. I can click square root, and that will automatically put in square root, the opening bracket for us, and we just need to close out with an ending bracket. So that's going to give us our actual stringer length, or the length of the stringer that we need. If we want to have 2 stringers, one per side of the stair, we can take and multiply our entire formula. So I'm going to put everything into brackets again and multiply it by 2. So I get the length of the stringer multiplied by 2 sides. And then since we're using a 16-foot board, again, I'm going to put everything into brackets and divide that by 16, and that will give me the number of 16-foot boards that I require. We've got length and we've got overall height being dealt with here. Because I'm specifying everything in feet, I want to make sure that my input length here is set to feet. And there's a nice complex formula for us that we can use to figure out our stair stringer length. Take and OK that. I've created my treads, my risers, and my stringers for my stairs that I need. Click OK. I've got a brand new assembly that I can OK and now attach to these stairs that I've got inserted. And when I run my report, I should get those parts for my stairs to show up in that report. So that is formulas for you. So we went over the fence and the different variables that are available for a fence and how we can create our formulas. Roof variables, many different roof variables that we've got available that we can use, things like ridge length, valley length, hip length, fascia and gable length, soffit areas, things like that. So we can use all those different variables to calculate roof products. Our walls, different variables for our area, whether it's an exterior area, interior area, interior length, exterior length, different variables like that. So each element's got its own little variables that can be used. And the stairs we went through, there was no assembly attached, so we actually went in and created an assembly so that we could calculate our treads, our stringers, and our risers for those specific stairs. So with that, I know formulas can be pretty complex, and getting able to figure out how to write a formula. So if anyone's got any questions, feel free to type those in, and I will do my best to answer those questions live right now. So I don't see any questions there yet. What I'll do is leave the panel open for another minute or so in case you're trying to get a question typed in. I just do want to mention again that after the webinar I will be sending out an email to all the attendees. Included in that email will be a PDF file. That PDF file has different examples that you can go through and try creating some of the formulas on your own. Also included in that email is will be the username and password for the webinar archive. We do record these webinars and try and get them up as soon as we can. So you can use that username and password to check out old or past webinars if you happen to have missed one or want to review one. Okay, so still no questions there. Hopefully everything's clear with formulas. So with that, thanks for joining me, everyone, and hope to see you next week for our Tuesday 2 o'clock webinar. Thanks, and enjoy the rest of the week. Bye for now.